Good morning, children. Sairam. Children, as I have told you that we have to study the preparation, properties and uses of some of the compounds which are formed by the elements of group 16. So, the first compound that we are starting with is dioxygen. Dioxygen, as you all know, is the molecular form of oxygen having two atoms of oxygen. Now, first of all, I'm starting with the preparation of dioxygen. Now, as you all can see on the screen, dioxygen can be prepared by heating oxygen salts such as chlorates, nitrates or permanganates. We have taken the example of permanganates. Instead of this, there can be chlorates or nitrates. They are heated in presence of manganese dioxide and they result in the formation of KCl. Here KCl and 3 moles of dioxygen gas can also be prepared. Now the second method is by the thermal decomposition of oxides of metals which are present low in the electrochemical series. Now children, the first example I have taken is of silver oxide Ag2O, which is thermally decomposed and it releases oxygen. Similarly, we can take the oxides of mercury or lead also. They will also result in the liberation of dioxygen gas. Now, the third method can be by the use of hydrogen peroxide. Hydrogen peroxide has the property that it readily decomposes into water and dioxygen by using catalysts such as finely divided metal with manganese dioxide. So the reaction is given here in presence of this manganese dioxide, the hydrogen peroxide decomposes and oxygen is formed. The next important method, the fourth method, is by the electrolysis of water. As you all know, the meaning of the word lysis is breaking. Electro means in presence of electricity. That means in presence of electricity, water breaks down and led to the release of hydrogen at cathode and oxygen is released at anode. So, we can use any of the method for the preparation of dioxygen. Industrially, dioxygen is obtained from the air by removing carbon dioxide and then water. The remaining gases, they are fractionally distillated and we get dinitrogen and dioxygen. So, these are the different methods that can be used for the preparation of dioxygen. Now coming to the properties. The properties, I am starting with point number 1. See children, dioxygen, as you all know, is present in the environment also in the atmosphere. It is colorless and odorless gas. The solubility in water is 3.08 ml in 100 ml of water. You can say approximately 4 ml in 100 ml of water, and it is just sufficient to support the vital support of marine and aquatic life. That means the aquatic life requires that much of oxygen which is actually present in dissolved form in water. You should know this thing also, that it liquefies at 90 Kelvin and freezes at 55 Kelvin. It has got 3 important stable isotopes. Isotopes, as you all know, are those elements, the forms which are having same atomic number but different mass number. So, oxygen has 3 isotopes having mass number 16, 17 and 18. Now children, the most important point is point number 4. Dioxygen is paramagnetic in spite of having even number of electrons. Now this question is very, very important. It comes in the board exam many a times, that why is molecular oxygen paramagnetic in spite of having the even number of electrons? Now children, the answer to this question comes from standard 11th, where you all have learned the you can say the molecular orbital theory. If you'll write the molecular orbital configuration of O2, you all will get to know that it has two unpaired electron in the anti-bonding pi star orbital. It has got two unpaired electron in the pi star anti-bonding orbital, so it is paramagnetic. It should be diamagnetic because it is having even number of electrons, but it is paramagnetic due to the presence of unpaired electrons in the anti-bonding pi star orbital. So you have to remember, if the question comes, why is molecular oxygen paramagnetic in spite of having even number of electrons? It is because of the molecular orbital configuration. It has got unpaired electrons in the anti-bonding pi star orbital. Now, point number 5, the properties we are doing. The fifth property, it reacts with almost all the metals and non-metals except some noble metals, as you all know, are silver and gold. Except for silver and gold, it can react with almost everything, or you can say almost all metals. And the reaction for reacting with metals is given here, that with calcium it results in the formation of calcium oxide, with aluminium it results in the formation of aluminium oxide. Similarly, with carbon it forms carbon dioxide. With zinc sulfate, when it reacts, it results in the formation of zinc oxide. And when with any organic compound it reacts, it results in the formation of carbon dioxide, and that is actually the combustion, carbon dioxide and water. Now, some compounds are catalytically oxidized, like sulfur dioxide is catalytically oxidized in presence of vanadium pentaoxide. It is one of the reactions that is used in the formation of sulfuric acid also, and result in the formation of SO3 gas. Now, coming to the uses. See children, you all know that dioxygen is very, very important for us. Without dioxygen we cannot survive. It is used in respiration. In the dioxygen gas also supports combustion. It is used in oxyacetylene welding, and in the manufacture of steel, in oxygen cylinders used by the deep sea divers, and in the hospitals. It is also used as a rocket fuel. Now, coming to the second important compound of oxygen, that is ozone. The molecular formula for ozone is O3, that is 3 atoms of oxygen are combined together. It is one of the allotropic form of oxygen that exists in the environment, but it is too reactive to remain for long time in the atmosphere at sea level. That means at ground level it is not stable. It is formed at a height of about 20 kilometers from sea level from atmospheric oxygen in the presence of sunlight. This ozone layer, it protects our earth from the harmful UV radiations. It does not allow the UV radiation coming from the sun to reach the surface of the earth. Now children, you should be knowing the structure of ozone molecule also. Now in ozone molecule, 3 atoms of oxygen are there, 1, 2 and 3. Now you all know 6 electrons are there with oxygen, 1, 2, 3, 4, 5 and 6. Similarly 1, 2, 3, 4, 5 and 6. Now for this oxygen, 2 atoms will be here. 2 atoms will be forming single covalent bond. That means a one double covalent bond with this oxygen, and the third pair of electron will form a coordinate covalent bond, and this bond can go to this side and this bond can go to this side. So it shows resonance, which makes it stable. Now children, the preparation of ozone. Now see how ozone is prepared. When a dry stream of oxygen is passed through silent electrical discharge, then oxygen converts to ozone. Only 10% of the conversion occur, and the product formed is called the ozonide oxygen. Children, you all can see the reaction for the formation of ozone from oxygen. This process is an endothermic process, so it is necessary to use the electrical discharge in the preparation to prevent its decomposition. Now children, if the percentage of the oxygen is greater than 10%, a battery of ozonizer can be used, and pure oxygen can be condensed in the vessel surrounded by liquid oxygen. Now children, coming to the properties of ozone. Ozone, when present in the form of a gas, is a pale blue gas. When present in the form of a liquid, is a dark blue liquid, and when present in the form of a solid, is a violet black solid. Ozone has characteristic smell, and in small concentration it is harmless, but if the concentration rises above 100 ppm, 100 ppm is 100 parts per million, breathing becomes uncomfortable and it can result in headache also. Now you have to remember, ozone is thermodynamically unstable and the decomposition reaction is exothermic, so high concentration can be explosive. If it is present in more amount, it can explode also. Now very important thing about ozone is it is a very powerful oxidizing agent because it can release a nascent oxygen. Now, thermodynamically it is unstable, it breaks down and produces dioxygen and the nascent oxygen. So it behaves as a powerful oxidizing agent. Now next important property of ozone is the oxides of nitrogen. They react with the ozone which is present in the atmosphere at a height of about 20 kilometers. So they can cause the depletion of the ozone layer. So this flying of jet airplanes in the stratosphere is considered to be the main cause for the depletion of the ozone layer. Now coming to the uses. Actually, one more thing, ferron is also used in the aerosol sprays and others. I'm sorry. It is also considered as one of the cause for the depletion of the ozone layer. Now coming to the uses of ozone. First of all, it is used as a germicide and disinfectant for the sterilization of drinking water. It is also used as a bleach. Bleach means decolorizing substance. Decolorization occurs because of nascent oxygen. So it is used in the bleaching of oils, ivory, flour, starch and other things. It acts as an oxidizing agent in the manufacture of potassium permanganate. So children, this was all about your ozone. Next, ozone, we have done the preparation, the properties and the uses. Next, I am starting with the sulfur allotropic forms, the allotropic forms of sulfur. Children, as such, sulfur forms numerous allotropes. That means many different allotropes are there, but of all those allotropes, the important ones are the yellow alpha sulfur and monoclinic beta sulfur. So we'll be studying about the alpha sulfur and beta sulfur. You have to remember both have got the formula S8. 8 atoms of sulfur are there in both the forms. Now see, alpha sulfur, it is also known as yellow rhombic sulfur. These crystals are formed by evaporating the solution of rolled sulfur in CS2. It is insoluble in water. You have to remember, this is the property of alpha sulfur. It is insoluble in water but dissolves to some extent in benzene, alcohol and ether. It is readily soluble in carbon disulfide. Now coming to monoclinic beta sulfur. It is beta sulfur. It is monoclinic. It is again formed from sulfur. It is one of the form of sulfur prepared by melting the rhombic sulfur in a dish, then cooling it. On cooling, the crust is formed. Then 2 holes are made in the crust and the remaining liquid is poured out. Now on removing the crust, the colorless needle-shaped crystals of beta sulfur are formed. Now children, you have to remember, alpha sulfur is stable below this temperature 369 Kelvin, and it transforms to beta sulfur if the temperature is above 369 Kelvin. So this temperature 369 Kelvin is called the transition temperature from alpha to beta. Now both rhombic and monoclinic sulfur, they have got the S8 molecule and the crown shaped structure. Now how is that crown shaped structure? See, 1, 2, 3, 4 and 5 atoms of sulfur are here. Similarly, 1, 2 and 3 atoms of sulfur are here. Now join them, 1, 2, 3, 4 and 5. Then 1, 2 and 3. So while joining these, we get the S8 structure. Here the bond angle between the 2 atoms is 107 degrees. So children, you have to remember, for both alpha and beta sulfur, the structure is the crown shaped structure. Now children, many other several modifications of sulfur are there, from having 6 sulfur atoms to 20 sulfur atoms, and atoms are having the rings which have been synthesized in the last 2 decades. The cyclo S6 ring that adopts the chair form, it is the most important one here, and many other forms are again available. Now you have to remember that S2 is also one of the form, and as the question comes for O2, similarly question comes for S2 also. When we were discussing right now the properties of O2, I have told you it is paramagnetic in spite of having an even number of electrons. Similarly, the same question can come for S2 also. Why is S2 paramagnetic in spite of having even number of electrons? Again, the answer is the same. It depends upon the molecular orbital theory by having 2 unpaired electrons in the anti-bonding molecular orbital. Now next, I am starting with the next important compound of group 16, the element, that is sulfur dioxide. Sulfur dioxide chemically is SO2. Now what is SO2? SO2 is an oxide of sulfur. How it can be prepared? It can be prepared from sulfur by treating with oxygen. The reaction for the preparation is S plus O2 gives SO2. It is formed together with a little of sulfur trioxide when sulfur is burnt in air or oxygen. Now in the laboratory, it can be prepared from sulfide ore with dilute sulfuric acid. When any sulfide ore when heated with dilute sulfuric acid result in the formation of sulfur dioxide gas. Now children, coming to the properties, you have to remember it is a colorless gas but has got a pungent smell and is highly soluble in water. It reacts with sodium hydroxide forming sodium sulfide. It reacts with chlorine in presence of charcoal and gives sulfuryl chloride, that is SO2Cl2. When it is moist, it behaves as a strong reducing agent and can convert Fe3 positive to Fe2 positive. It can also decolorize the acidified potassium permanganate. That means it is reducing it. So these are the properties of sulfur dioxide. Now uses. It is used in the refining of petroleum and sugar. It is used in the bleaching of wool and silk also. It is used as disinfectant and preservative. Liquid sulfur dioxide is used as a solvent also to dissolve a number of organic compounds and inorganic chemicals. So this was all about sulfur dioxide. Now Now children, next important compound that we have to study is sulfuric acid. Sulfuric acid, previously the preparation, the manufacture, properties and uses, all three things were there in the syllabus, but this year the manufacture is not there, only the properties and uses are there. We'll proceed with this the next time. So till then you complete your written work, use these notes to complete the work. Then we'll be discussing some of the important questions which came in the previous year examinations. Thank you. Sai Ram.